Welcome to Oracle Emergency Troubleshooting series. In this video, we're going to see how to troubleshoot any performance issue at a much deeper level. Okay, so we are going to identify the SQL and the timeline of the SQL and what is the main cause of the SQL that is being slow, right? So we are just going to execute a set of queries, which is a chain of queries, which will help us in identifying the cause of the issue in a sequential way. Okay, so you can imagine that when there is some performance issue on your database. So let me explain the different scenarios when performance issue happen, right? So these are the kinds of performance issue that we analyze. Okay, first one is historical, second one is intermittent, and third one is sudden or present. Okay, so historical issues are something which we cannot change. Okay, already the issue had happened, and we just need to analyze what exactly caused that issue to prevent that issue to happen in the future, to not happen in the future, right? So it is completely a past issue analysis. Okay, so if the issue again occurs, then that will be an impact. Okay, already there is an impact which happened already, so we need to identify the impact. And coming to intermittent, so this is kind of not continuously. The issue will happen it will happen with interval. Okay, so say for example the issue happened at 5 p.m. Okay, so it will be some set of small intervals. So at 5 p.m. The database was fast. Okay, so but the issue happened between 5 to 5 p.m. Okay, then 5 to 5:10 p.m. it was fast, and again 5:10 to 5:15 the database was slow. So this is kind of an intermittent. It will be up and down. Okay, sometimes it may run good, sometimes it may run bad. Okay, next one is sudden. So sudden means it's kind of a present, right? So currently the issue is going on, and you are interactively working on the issue. Okay, so you need to do something immediately to focus and solve the issue, right? So these are the different kinds, and we use ash for both sudden and intermittent issues, not completely historical. Okay, so we can also use hash details for the historical analysis, but still this ash is somewhat a sample based collection, so it will give us more granular information compared to AWR. And we can also use $$ session. So $$ session are the best for the current issues, like $$ views, right? So $$ session, $$ SQL, $$ process, right? So here also we are going to use $$ active session history. So active session history will sample all the performance diagnostic data in a regular interval. So it is kind of a near past data. Okay, it is not the immediate or the current data, so it will record only the near past data. Say for example the last 5-second data it will sample, something like that, right? So $$ sessions are current, completely current. Okay, so let us just see how we can use this set of queries to identify the root cause of a particular issue. Before that, let me run any sample workload. Okay. So yeah, I executed the sample workload. Okay. Now we are going to set the definitions before we use the queries. Okay, the first query that we are going to use is to make sure that all the samples are collected. Okay, so we are just making a sanity validation. Okay, so this is a sample sampling interval. Okay, so we need to give the timings of the issue. Okay, so between this interval almost 2000 plus samples are collected. Okay, 617 to 621, the last 5 minutes samples. Okay, and then we are going to profile the sample data with CPU and wait. Okay, so database either consume CPU or it will wait for something, either IO or latch or logs or any other wait events. So total samples are 2800, and out of those total samples only 868 samples are CPU and remaining samples are wait, which means this will indirectly help us in giving some hint about the ratio, right? So the proportion of wait is higher than CPU, which means the database has waited more time compared to the CPU. Okay, so I mean that is between these two timeline. Okay, and if you see the next one, the wait class, right? So we are just checking whether the session is waiting or it is on a what wait class it is and what are all the samples. So if you see, the top one is user IO. So as I already mentioned, either the database will consume CPU or it will wait on other wait events. So here the top one is IO. So this is expected. Okay, every database will be having IO issues. It's not IO issues, but our database has to go through IO, right? Without IO there is no disk and memory communication, right? So user IO is the top. So next we'll check the top offenders. So what are all the SQLs which are responsible? So here if you see, the top event is direct path read, and almost this SQL has consumed 1800 samples. So this means that majority of the database activity has been consumed by this SQL. So if you see, even in the second, third and fourth, all these SQLs are same, and even this one, right? So it has gone through multiple wait events. Okay, so first one is IO, second one is commit, third one is NQ, fourth one is shared pool wait. Okay, so now we can focus on this SQL and why it is taking, why it is going through direct path read. So direct path read is an expected event because obviously if the data is not in the memory, then Oracle has to query it or scan it from the disk. So obviously direct path read is a sorting event. So when we use parallel, right? So parallel queries use direct path read because it uses PGA rather than SGA. So directly it will bypass the SGA and scan the data from the PGA. Okay, so there will be a PGA IO. So that's why direct path read is used. And second, if you see, the SQL has consumed almost 858 samples on CPU. Okay, so yeah, this is fine. Okay, obviously every SQL that executes needs to consume CPU. So since this SQL didn't get the data on the memory, so it is directly doing this IO, direct path read. Okay, and majority of the samples are direct path read, and also you can see NQ. on log file sync. Okay, so enqueue, it's kind of a slave process array. So this is kind of a internal enqueue event. Okay, so next let us just substitute the SQL ID and see the timeline. Okay, so let us go more, let us just query more depth of this SQL information. So this is the SQL. Okay, so this gives us more detail about the SQL that has been executed earlier. So if you see the last 5 minutes, a lot of samples are collected for every second. Okay, so each and every second you can get the details. Okay, and also you can see if there are any blocking sessions here. So even this SQL has gone through some blocking sessions. Okay, so here you need to understand what is causing the SQL to be blocked, right? So you can also substitute the block session ID and get the blocking session information from DBA hist active sys history, where session ID is equal to this 39. So now if you see, when you see session 39, it has executed other SQLs. Okay, apart from this CFP4 SQL, it has also executed other SQLs parallelly. So that's the reason this SQL is having a blocking session. Okay, so yeah, this is the diagnosis part of the issue. Okay, so further action, we need to identify, okay, what exactly is. So here you can see all the sessions are executing multiple parallel queries, right? So obviously there will be a slowness on the database. So we need to identify why all these sessions are executing at the same time. Okay, so we also need to make sure that the resource is sufficient to support the parallel consumption, right? So yeah, this query gives us the information about the total samples, CPU percentage, weight percentage, IO weight percentage, parse percentage, all these information. Okay, so it does not substitute it properly, so we just need to make sure that we are executing the query in a proper way. So let me just open a notepad and correct this SQL. So there is some space issue in the query. Okay, so now let me again execute this. Okay, so again we are getting the same issue. Let me execute the first one, and okay, so if you see, so let us just remove certain clauses from the query. Because few of the information may not be needed. Okay, Okay, so I just removed the unwanted information. So now if you see the last sample collected and how much percentage of CPU has been consumed within this 4 samples. Okay, and also weight percentage is 25. So this gives us the proportion and the ratio. Okay, and the 25 percentage of that weight event, almost 100 percentage of IO weight has been consumed out of this 25 percentage. Okay, so I hope I'm not confusing. When it comes to weight, it can be further categorized into IO and parse weight, right? So in parsing it is 0. This almost all the 25 percentage comes under IO. That's it. Okay, so this gives us the ratio of what exactly the issue category. Okay, so issue category may be either IO or logs or parse or anything that any other category that can be that can happen, right? Okay, so these are all the different queries which will give us some valuable information. So we can take all this analysis and we can just come to a conclusion. Okay, so this will take quite some time, okay, for the analysis. This is not an immediate solution giver method, okay, but it will give, you need to further eyeball each and every values under this the data that is shown here, right? So you need to further eyeball and check when exactly the issue got happened. So here I have just queried all the information here. Okay, so you need to work with the application user to further identify the root cause. Okay.